Hey guys, so last time we talked a little bit about covalent compounds, and today we're going to talk a little bit more about covalent compounds. We're going to talk about a few different ways to represent covalent compounds. Two different ways that we're going to talk about here. We're going to talk about how to say their names, or how to write their names, and we are going to talk about how to draw what are called Lewis structures. It's a little picture of a molecule that'll help us understand how things are set up. And that's our target for today, is to be able to draw these Lewis structures. So let's take a look at some of this. Okay, when we named ionic compounds, it was really pretty simple to name those ionic compounds. Really all you did is you saw that there were two different elements in the ionic compound, and you named each of the elements, and then the second one you changed the end of the word to "ide," and that was as simple as it was. With covalent compounds, though, you can have more than one different compound made up of the same two elements. So naming it the same way would not tell you which one you were talking about. For example, if you had a compound, and these are two compounds here, CO and CO2. These are two very different compounds. If you named them the same way we named ionic compounds, you would call them both carbon oxide, and it wouldn't tell you which one you were talking about. So what we do when we name covalent compounds is we'll use a prefix in the name to tell us how many of each element is in that compound. So the first one, CO, and the second one, CO2. We use a prefix to tell us how many of each element. But one weird thing about how we do this, because there's always one weird thing about how we do this, is in the first word in the compound's name, we never use mono. We never use, if there's just one, mono in the first word. So when I look here, I would call this, you see there's just one carbon and one oxygen. So I would call this monocarbon and then monoxide, right? But like I said, weird thing, we don't use mono in the first word. So I would call this carbon and then monoxide. Oftentimes when we have an O at the end and an O at the beginning, we just drop one of the O's. So instead of saying monoxide, we'll say monoxide. So that one there is carbon monoxide, right? This one here, again, we don't use mono in the first word. You see there's just one carbon, so I'm not going to say monocarbon. I'm just going to say carbon. And awkward. Okay. CO2. So we're just going to write carbon. We don't use mono in the first word. And then there are two oxygens. So I'm going to call that dioxide. Okay, so you can see we use the prefix to name, to indicate how many of each atom are in there. We don't use mono on the first word. And then we always use a prefix on the second word and change the end of it to ide. So instead of oxygen, oxide, right? Let's take a look at another example here. Let's take a look at this one here. Okay, N2O4. So N is nitrogen, and there's two of them. So I'm going to use the prefix di. Okay, keep in mind, it's only mono that we don't use in the first word. If it's any other prefix, we write it down. So two nitrogens is dinitrogen. And then we have four oxygens. And we're going to change the end of the word to ide because it's the second word. So the prefix for four is tetra. So I'm going to make this tetraoxide. Okay. And I'm going to drop the A at the end of tetra because tetraoxide is a little awkward. And we're going to make it tetroxide. Now, if you don't get, dropping a vowel right there, like I just dropped the A, that's fine. If you could get tetraoxide or monoxide, I'm perfectly happy with that, right? But when chemists do it, you'll see they'll drop a letter just to make it sound less awkward, I guess. right? Yeah, so N2O4, dinitrogen tetroxide. Okay, now you try it. Here's 3 different compounds. Pause the video, figure out the names for these 3 compounds, and then, resume and see if you were correct. Okay, so pause the video, see what you get, and then we'll talk about what the answers are. Okay, hopefully you paused the video and figured out what these 3 are called. Let's go ahead and take a look. This one here, P is phosphorus, and there's just one. You might call it monophosphorus, but we're not going to use mono in the first word. So we'll just call this phosphorus. And in the second one, hydrogen, we're going to change the end of the word to "ide," so hydride. And there's 3 of them. So it's trihydride. So that one is called phosphorus trihydride. The second one here, we've got 2 hydrogens, so it is dihydrogen. And then we've got 1 sulfur, so we're going to change sulfur to sulfide because it's the second word, and 2 of them, we'll call it disulfide. So that one is called dihydrogen. Oh yeah, I'm sorry, there's only 1 sulfur. So we'll call it monosulfide. So that one we'll call dihydrogen monosulfide. Okay, third one here, we've got 2 silicons. So we'll call this disilicon. And we have 6 bromines. We'll change bromine to bromide because it's the second word. And 6 of them is hexa. So we'll call this hexabromide. So we'll call that one disilicon hexabromide. Keep in mind with these, we're only doing compounds that have 2 different elements. It's entirely possible to have compounds with many different elements, right? We're just kind of sticking with compounds that have 2 elements that we're going to name this way. Okay, let's talk about another way that we can represent covalent compounds. We can represent covalent compounds with what's called a Lewis structure. It's also called an electron dot diagram. And these diagrams show us what the different atoms in a compound are doing with their electrons, like who they're sharing their electrons with, right? The way that we draw these, let's say I have some element. It doesn't really matter which element. I'm just going to put an X. There's no element X, but it could be any element, okay? We had mentioned in our last video that all of the different elements are trying to get 8 valence electrons. Okay, remember we said valence electrons are the electrons in the atom's highest energy level in the s orbital and the p orbital. And if you remember, s orbitals can hold 2, p orbitals can hold 6. 2 and 6 gives you 8. So they're all trying to get 8 electrons. Well, what we're going to do is we're going to put some dots around the symbol for the element. And we can put as many as 8 dots. Okay. And when I put dots around it, the dots represent the valence electrons. So they're all trying to get 8, right? So let's say this one has 8. I'm going to put dots around it. I can put 2 dots above it. I can put 2 dots below it. I can put 2 dots on the side. I can put 2 dots on the other side. So when I put dots, I always put 1 dot on each side before I put a second dot on that side. And these dots represent those valence electrons. So now you can see this particular atom here has 8 dots around it. It has 8 valence electrons. It's got 2 on each side, right? The exception to the 8 rule is hydrogen, because hydrogen doesn't have a p level. Hydrogen, we're talking about hydrogen here, can only have 2 electrons, right? So we're going to put, it doesn't matter if you put them on top or bottom or left or right. So we're going to put 2 for the hydrogen. Okay. And what we do is we write the different symbols next to each other to show which electrons are being shared. So let's say we want to write, we want to draw a Lewis structure for a particular compound. Let's take a look here. Okay, let's draw the Lewis structure for this compound, NF3. We would name that nitrogen trifluoride. Okay, well, when we draw the Lewis structure, we're going to start with what we call the central atom. Okay, the central atom is usually almost always the first one. Technically, it's the more electronegative one. And usually, almost always, that's the first one. So we're going to start with nitrogen. This is my central atom in my Lewis structure. Okay. Now, I'm going to put dots around that N to indicate how many valence electrons it has. But I need to know, how many valence electrons does nitrogen have? We're going to need to look at the periodic table to figure that out. So let's go take a look at the periodic table and figure out how many valence electrons does a nitrogen atom have. Okay, so here is nitrogen on my periodic table. How many valence electrons does it have? Well, these ones, the noble gases, have 8 valence electrons. These ones, the halogens, have 7 valence electrons. The chalcogens have 6. The pnictogens have 5. The carbon group has 4. The boron group has 3. Forget about these. The alkaline earth metals have 2, and the alkaline metals have 1. We're never going to have to worry about these ones over here. It's just the non-metals we're going to worry about. So, where's nitrogen? Right here. How many valence electrons does it have? 8, 7, 6, 5. Nitrogen has 5 valence electrons. So let's go put some dots around our N. All right, so our nitrogen has 5 valence electrons. I'm going to put 5 dots around it. Okay. So remember, I'm going to put a dot on each of the 4 sides before I put a second dot on any side. So 5 valence electrons. 1, 2, 3, 4, and 5. Now, I started on the top. It doesn't matter which side you start on. It doesn't matter. Okay. Now, we're going to put some fluorines here. Okay, I need to go and take a look at how many valence electrons does a fluorine have. So let's go take a look at that on the periodic table. How many valence electrons will my fluorine atoms have? Here's fluorine right here. So how many valence electrons does it have? It's 8, 7. 7 valence electrons for fluorine. So let's go put our fluorines and we'll draw 7 dots around them. Okay, so I'm going to draw fluorines with 7 dots around them. I have 3 fluorines to do that with. Where am I going to draw them? Well, check this out. See my nitrogen here? We can have 2 dots on each side, and there are 3 sides that don't have 2 dots, and I need 3 fluorines. So I'm going to put a fluorine right here. I'm going to put a fluorine right here, and I'm going to put a fluorine right here. And those fluorines get 7 dots around them, right? So let me draw 7 dots. 1, 2, 3, 4, 5, 6, 7. Now remember, all the different atoms, except for hydrogen, are trying to get 8 valence electrons around them. Now look at my fluorine. We put 7 dots around it, but how many dots are around it now? 2, 4, 6, 8. You can see these 2 dots are being shared between the nitrogen and the fluorine. It's a shared pair of electrons. This is a covalent bond. And when we do that, when we have the pair that's being shared, we'll take those 2 dots away and replace them with a line. That line indicates there's a bond here. So that line stands for 2 electrons being shared. Okay. Now I've got 3 more fluorines to do, right? I'm going to put one here, I'm going to put one here, and it's going to end up being pretty much the same deal as what we just did. So over here, let me put my other fluorine, and we'll put 7 dots around it. 1, 2, 3, 4, 5. This side already has 2. 6, 7. Okay. So now this fluorine has 8 dots around it. It's got 8 electrons around it because that one from the nitrogen is now by its, and that makes 8. So let's take this shared pair of electrons and turn it into a bond. Okay, and my third fluorine I'll put down here. Okay, and I'll put its 7 dots around it. 1, 2, 3, 4. This one always has 2. 5, 6, 7. And then you can see these two are being shared between the nitrogen and the fluorine. We'll turn that into a bond. And there you have it. Okay. Now at the end, when you're done with these, each of the different atoms should have 8 dots around it, except for hydrogen. Hydrogen would have 2 dots around it. So let's take a look. Let's make sure each one of them has 8 electrons around it. And remember, a bond is 2. Okay, so here's 2, 4, 6, 8. So this one has 8. There's 2, 4, 6, 8. So this one has 8. This one has 2, 4, 6, 8. So it's got 8. And what about the nitrogen in the middle? Now, remember, it started with 5, but now it has 2, 4, 6, 8. So now they're all good. They all have 8 electrons around them. So there we go. That is a Lewis structure. Okay, let's go ahead and do a couple more examples. I have the 3 here that we named earlier: the phosphorus trihydride, dihydrogen sulfide, dihydrogen monosulfide, and the disillicon hexabromide. Let's draw the Lewis structures for these 3. Okay, so for the phosphorus trihydride, our central atom that we'll start with here is the phosphorus. If we go and look at the periodic table and find phosphorus, it should have 5 dots around it to start with. So let's start with a phosphorus here with 5 dots. 1, 2, 3, 4, 5. And then my hydrogen, there's 3 hydrogens. Clearly I'll put 1 here, I'll put 1 here, and I'll put 1 here. If you look at where it is on the periodic table, it's in the first column, it's got 1 dot. And you remember, hydrogen is the odd one. It's not looking for 8 dots around it, it's looking for 2. Right? So let's do these 3 hydrogens. I'll put the first one right here. And it comes with just 1 dot, which I'll put right here. Okay. So now you can see the pair of dots. We'll turn that into a bond. I'll put my second hydrogen down here. And here's its dot. And we'll turn that shared pair of dots there into a bond. And I'll put the third one over here with its dot. And we'll take those 2 dots and make a bond. Now let's go through and make sure that each atom has the number of electrons that it wants, right? Everything except for hydrogen wants 8, but hydrogen wants 2. So this hydrogen right here, that bond is 2 electrons, so it has 2. This hydrogen, that bond is 2 electrons, so it has 2. This hydrogen has 2. And then the phosphorus would need 8. So let's take a look. There's 2, 4, 6, and 8. So they're all good there. And there's your phosphorus trihydride. Let's take a look at this dihydrogen monosulfide here. Okay. Now usually the first one is the central atom, but you're going to have an awful hard time doing that with 2 hydrogens, right? So we're going to make this here sulfur, the central atom. So we'll start with this sulfur. And if you find sulfur on the periodic table, it's a chalcogen, so it's got 6 dots to start with. 1, 2, 3, 4, 5, 6. Okay. Now, these 2 sides already have 2 dots, so my 2 hydrogens are going to go here and here. Okay, and remember, hydrogen comes with 1 dot. So I'll put the first one here. I'll put the second one over here. And then I'll change those shared electrons into bonds. So this hydrogen has 2 electrons, this hydrogen has 2 electrons, and the sulfur has 2, 4, 6, 8 electrons. So there, they're all good. Now, you might draw these in slightly different ways. I mean, I end up with mine here with a right angle. If you had drawn it in such a way that, say, this hydrogen had ended up on this side and ended up with a straight line, that'd be fine as well, right? Maybe you end up with this guy on top and this guy on bottom. That's fine as well. So not all of our drawings might look exactly the same. You might have this one upside down with the hydrogen here on top and this 2 dots on the bottom. That's okay. They're really kind of the same thing. They're just mirror images of each other. Okay, let's do this third one down at the bottom, the Disillicon Hexabromide. Okay, here, slightly tricky. We're going to start with the silicon, but there's 2 of them. So I'm going to start with 2 silicons. And silicon comes with 4 valence electrons. If you find it on the periodic table there, it's in the column that has 4. So I'm going to start with my first silicon. I'll put 4 dots around it. And then I'll do my second silicon right next to it, also with 4 dots. And you can see the 2 of them are sharing a pair of electrons. So we'll turn that into a bond. Okay. Now I need 6 bromines. And if you look at where bromine is on the periodic table, it comes with 7 dots. It's a halogen. So it's got 7 dots. And if we take a look, we need 6 of them. And how many open spots have I got that I can put them in? I've got 1, 2, 3, 4, 5, 6. Well, doesn't that work out nicely? So I'm going to put 6 bromines. Each one's got 7 dots around it. So start up here. 1, 2, 3, 4, 5, 6, 7. I draw them kind of small. There's a lot of them, you know. 4, 5, 6, 7. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, that's a lot of dots. Now let's go through and let's take those shared pairs and turn them into bonds. So here's one, here's one, here's one, here's one, here's one, and there's one. Okay. Now, if you go through and you count up for each one how many electrons around it, they've all got 8, right? So each bromine has 3 pairs of dots on a bond, 3 pairs of dots on a bond. That makes 8 electrons. And then the 2 silicons both have 4 bonds around them. So 4 pairs is 8. So they've all got their 8 electrons that they're looking for. So some fun stuff here. Okay, so there we talked a little bit about how to name our covalent compounds with the prefixes and how to draw the Lewis structures to represent them. So hopefully that helps us to be able to draw the Lewis structures for the covalent compounds. So until next time, take it easy.